In this study, we introduce a novel interactive segmentation approach that can autonomously learn how to interact with a dense clutter to improve the instant segmentation quality of the scene. Our push-to-see model has two main parts: mask-RG, which is a mask-RCNN-based reward generator that was trained offline by only using depth images, and push-to-EQN, which is a deep Q network trained to predict best pushing actions that decrease the segmentation error in the consecutive scene. The Q-value optimization has been done through trial and error using deep reinforcement learning with reward signals generated by mask-RG. In the first demonstration, the heuristic baseline pseudo-randomly generates pushes towards the highest point of the heap. When the task is easy, this baseline can singulate the heaps, but in this case we have a dense clutter which includes 28 objects and the mask threshold is set to 0.85. Thus it fails to decrease the segmentation error sufficiently in 30 trials. The objects that are colored in different shades of red in the top right panel are the false positives, which are the objects that cannot be detected by mask RCNN. In the second demonstration, we tested VPG, the visual pushing and grasping model. We did not restrict the model to perform grasping actions, since decreasing the number of objects through pick and place would also help to improve segmentation. On the other hand, this baseline also failed to singulate objects sufficient enough to solve the task in 30 actions. As can be seen in the video, when the objects are densely piled together, grasping becomes more challenging. In the third demonstration, we show how our model performs in the same dense cluster. Unlike baselines, push-to-see successfully completes the task after predicting 17 pushing actions, and it detects all the objects at the end of the task. In the fourth demonstration, we use the same colored VPG objects in order to show how push-to-see tackles textureless objects that don't have any distinguishable features. Our model singulates the scene with only 9 pushing actions in this case. The last one is a sim-to-sim demonstration. Here we transferred our model to a new robot, Franca Panda arm, and to a new environment, which is our simulation framework based on PyBullet engine. We should emphasize that we only transferred push-to-EQN with the weights that were already acquired in VREP simulation with INRIA objects during training. Here, without mask-RG or any further training or fine-tuning, our model is able to successfully singulate the clutter.